Our next problem involves taking the graph of a function, and I hope you can read what's going on this graph. This is the graph of a function whose domain is from -4 to +4 with possible exceptions we'll talk about. And we're first trying to decide what are certain values. For example, I want to read what the value of the function at -3 is. And this should be visible from the graph. Then -1, +1, and +3. So what I'm looking for is the x-coordinate is -3. This gives me the y-coordinate. And hopefully the graph does as well. I'm looking for a point that has an x-coordinate of -3. I'm following this, but I find that there's a hole here. No, this is not where the value of the function is at x equals -3. In fact, for some reason, there it is. This point has an x-coordinate of -3 and a y-coordinate of -2, and that's what we mean by f of -3. f of -1. Okay, I'm looking for a point that has an x-coordinate of -1. Well, there's -1, and here's that point. Try and make it a little clearer. Yeah, there is a point there. The y-coordinate of that point is 3, and that's what we mean by f of -1. It's the y value that goes with an x value of -1. So far, so good. Let's try f of 1. I'm following this guy down. There's a hole here at 1, so no help there. I start looking elsewhere, and I find that, in fact, there's no help there either. There is, in fact, no point on the graph that has an x-coordinate of 1. So 1 is really not even part of the domain of this function. And I've got equal. I better remove the equal because really there isn't anything equal to it. We'd say that this value is not defined, or any of various other ways of saying the same fact. f of 3, again, I'm looking for a point that has an x-coordinate of 3. And am I going to have any luck with that? I think there's where that point is. I'm going to say that that's where the point is. This has an x-coordinate of 3 and a y-coordinate of -1. And that's what we mean. What is the y-coordinate of a point that has an x-coordinate of 3? So we can evaluate the function based fairly well on the graph. I have other questions I'd like to address here. You'll hear questions about where is the function increasing or decreasing. We're always picturing ourselves moving to the right on the graph. The function is increasing if, in fact, you're going up in that portion. And I can see here that I'm going up. So I'm going to say that the function is increasing starting at -4. And I'm getting here, and I say, well, I can't include 3 because I'm not going up at point 3. Excuse me, -3. But after -3, I continue going up. So I'm using this union notation from 3 until -2. I want to suggest that this is where I stop going up. So from -3 to -2, I continue going up. -2 is included in this interval because every point in this interval, if it is to the right of another point, it takes on a higher value. And of course, there is nothing to the right of -2 in this interval. Okay, there's the increasing part. Everything else is downhill. As I move from left to right, I am decreasing, going down from -2 until +1. So I'm going to say that I'm decreasing, or the function is decreasing from -2 until 1, but that point is not included in this piece, so I show it rounded off. It perks up again on the other side of 1, however. It's going down in this piece. So from 1 to 4, it's decreasing. So this is all I was looking for, all the information I was trying to get out of this graph. Finding certain values of the function. Also